Extraction of metals at top of activity series. Extraction of sodium. The ore of sodium is rock salt. The extraction of sodium comes under the category of extraction of metals at the top of the activity series, which involves elements like potassium, K, sodium, Na, calcium, Ca, magnesium, Mg, and aluminium, Al. Simple chemical reduction methods like heating with carbon, carbon monoxide, etc. to reduce the ores of these metals are not feasible. The melting point of rock salt is 801 degrees centigrade. The temperature required to melt for the reduction is too high and more expensive. To make the process economical, electrolysis methods are to be adopted. Again, the electrolysis of their aqueous solutions is also not feasible because water in the solution would be discharged at the cathode in preference to the metal ions. The only method available is to extract these metals by electrolysis of fused compounds. To extract sodium, that is Na, from sodium chloride, that is NaCl, fused sodium chloride is electrolyzed with steel cathode as negative terminal and graphite anode as positive terminal. Now, let us see the process of extraction of sodium. This is the industrial setup. The power supply unit consists of push buttons to on and off, indicator lights, ammeter to indicate current supply, main switch. Electrolytic bath, which consists of electrodes placed inside such as steel cathode and graphite anode. Let us proceed for the process. Turn on the main switch, red light glows and which indicates input power supply. To carry out electrolysis process, a large quantity of electricity is required to keep the ore in molten state. In order to compensate the high electricity consumption, suitable impurities are added to the ore to decrease its melting point and pre-melted in the special chambers. Bring the pre-melted molten sodium chloride solution and pour it into the electrolytic bath. Immediately press the green color push button. Green color light glows, which indicates the supply of electricity to the molten sodium chloride solution. When the electricity is supplied, the electrodes get heated further and the solution undergoes electrolysis process. The sodium and chlorine dissociates into respective ions in the form of bubbles. That is, sodium ions Na+ and chloride ions Cl-. As the reaction is in progress, the dissociated sodium ions move towards steel cathode and the chloride ions move towards graphite anode. The metal Na will be deposited at cathode and chloride will be liberated at the anode. The chemical reaction is as follows. At cathode, 2 Na+ reacts with 2 E- gives rise to 2 Na. At anode, 2 Cl- gives rise to Cl2 plus 2 E-. We can observe that the sodium ions which are deposited on the steel cathode appears as white substance, whereas chloride ions deposited at the anode forms bubbles at the graphite electrode. The white colored substance present on cathode can be processed further. This is how the process of extraction of sodium can be carried out by using electrolysis process.